In this video, I'd like to talk about the math question of the day for March 5th, 2023. And with this question, we need to find the slope of the line containing the pair of points 5, 2 and -3, 7. So to answer a question like this, you need to have an understanding of Algebra 1, particularly linear equations, two-variable linear equations, and their graphs. So at this point, go ahead and pause the video, see if you can work through this on your own, and when you're ready, we can go through this together. Now, assuming that you have attempted the problem, we can start working through it. And if you do have suggestions for future questions of the day, feel free to leave those as a comment. Now, we need to find the slope of the line containing these points. If we want, we can draw a quick sketch of this. So let me draw in a coordinate plane with these 2 points. And if we plot this one here in green, it's at 5, 2. Right here, we can plot this in a pink color at -3, 7. It's up here. And we're looking for the slope of the line between these points. Or in other words, we are looking for the steepness of the line that goes through these 2 points. And we can define slope in several different ways. We can say that the slope is the rise divided by the run. Or in other words, it's how much the y values change, or the change in y values, divided by the change in the x values. This Greek letter delta just means change in. So we have the change in the y values divided by the change in the x values, or we can even look at specific coordinate points. Let's say we have y1, and we have another point at x2, y2. Then the difference in the y values, we just take the bigger one and subtract the smaller one, and we do the same for the x values. We have x2 minus x1, though I should be careful. This value for x2 and y2, this doesn't necessarily have to be bigger than x1 and y1. We just labeled it x2, y2 arbitrarily. Just make sure you're consistent with these. If you label this x2, then this has to be y2, and both of those have to be first when carrying out this subtraction. But if you switch the order, that doesn't matter. We can do x1 minus x2, but if we do it this way, then we have to do y1 minus y2. So be careful if you are switching the order there. And at this point, we can just label that this, let's say, is x1 and this is y1, and we can say this is x2 and y2, and we can just plug those into our formula. So we can find the slope, that this is y2, which is 7, minus y1, which is 2, and we can divide all of that by x2, which is -3, minus x1, which is 5. So here we get 5 up top and -8 down below. And since there's one negative, we can put it out in front, or we can attach it to the numerator. It doesn't really matter. But now comparing it to our rise over our run, I like to put the negative with the rise part, if there is one. And a negative rise just means that we are going down 5, and then we have +8 for a run, meaning we are going over 8 units. And we can see that's true based on our picture here. We go down 5 units, we're up at 7, and we go to 2. And then from -3, we go all the way to 5. So you can see we go down 5 and over 8, which matches up with what we found in our formula. So we can feel fairly confident that -5/8 is the slope of this line.